All right, so we're gonna look at the specimen here. This was tested in the shock tube. This was actually tested 7 times. So this would be the inside space of a building, the protected space. This is our door, is in our vestibule. And you can see the door is still operational, even after being tested as many times as it was. So this wall was tested up to blast pressures of 20 PSI, impulses of almost 1400 PSI milliseconds, which is a huge load in terms of both pressure and duration. The way that we constructed this is a precast wall, and all the holes around the perimeter, those were used for bolting into the shock tube. And the reason we did that was to mimic the boundary conditions that you'd get in an actual vestibule. So this vestibule is cast as one entire piece, which means you have continuity and fixity around all the edges. And so we wanted to mimic that by bolting it to the shock tube with these steel plates here. This next wall that we're going to look at here, this is a specimen that's tested in the shock tube, again, 5 times. You'll see a number of cracks on it, and that's because we hit this with the design basis load 5 times. The impressive thing about it is that the wall is still really resilient. It's been standing out here for a couple of years. It would hold up against any kind of environmental loads. This is the joint that is the basically the mating surface between 2 of the precast modules. So the precast modules are seated adjacent to one another. They're bolted in place, so there's no welding at all. It's all bolted. And so you can see the bolts there. And then within this joint, we've got a series of fire ropes and intumescent caulks in there, and then also a weather seal as well. So that joint itself is also very resilient. We don't have it out here, but we also tested this wall with a jet fire with a direct impingement to test that joint, and the joint held together very well there again. So when we ran our shock tube test, what we wanted to do is really test this joint and exercise that. So the specimens that you see are essentially a slice halfway between each of these walls. So slice there, a slice there, and we're loading this entire surface as though there's a pressure from the outside of the building. And so again, we're exercising this joint, seeing if it holds together, and then if it would, survive the blast test, and you'd still be able to use the building as intended after the design basis event.